conseguimos resolver os problemas. Tá.
Bom, novamente, muito obrigado pela presença de vocês no painel automotivo.
Here, this is the automotive panel, FAPLAR 2024. So now we're going to begin our panel with a talk from Professor Walter Vilar. He's a PhD in chemistry, and he's authored many books on polyurethanes, and he's one of the biggest polyurethane suppliers that we have. He's going to talk about the chemistry of polyurethane in the automotive industry. Thank you. So once again, I'd like to apologize for the technical problem that we had. I'm going to introduce myself. You can see my name up on this screen, Walter Vilar. I studied chemistry, chemical engineering. I have PhD, post-PhD, everything in chemistry. I started working in polyurethanes back then. And back then, there was no literature available. So back in the 90s, I decided to write the first edition of the book, Chemistry and Technology of Polyurethanes. Back then, it was sponsored by a company that no longer exists. In 98, I had the second print edition, and 2002. And 2004, I decided to no longer have a print edition. I decided to make it available on the web. You can see the website up on the screen. It's easy to remember, polyuretanos.com.br. So, free access to the entire book. While I'm able to, I will maintain free access to this book, because I want to focus on promoting the information about polyurethane. We have polyurethane technology, market. Can you turn this for me?
Se não tiver como, deixa. Se não tiver como... Deixa então. Tá. Tá, obrigado. Nós temos a parte de mercado. Falamos dos...
We have the market part. We talk about isocyanates.
Falamos dos polióis.
Polyols. We talk about all additives. And then we talk about all the different processes. Flexible foams and in blocks. And then I go into molded polyurethane, where the main use of molded polyurethane is the automotive industry. The furniture industry also uses a lot of molded polyurethane, but without a doubt, the automotive industry is the main one, the main user. I like to say that polyurethane is the world, and when we consider the isocyanates, we have the most common, which is MDI. MDI, we have polymeric MDI, and if in case you have any questions, please interrupt me. We have polymeric MDI, and we have raw MDI. I like to say that because sometimes it's misleading. People have called me before asking, what's the difference between raw MDI and the other names that they use in Portuguese? It's actually the same thing. It's widely used, especially in automotive systems. as it's the safest isocyanate to work with and the lowest cost. And there's the modified forms of MDI that sometimes go into systems together with the polymeric MDI to enable adjusting the formulation. So when you're creating a system, let me go back a little. When did the use of PU started? It started way back. I didn't even work with that back then. I was still a child back in the 50s. And the first raw materials started being manufactured. Isocyanates, polyols, additives, and the manufacturers of raw materials. Their interest was to convey knowledge about how to formulate by using polyurethane. And the first segment that was developed in polyurethane was the flexible foams as a block for mattresses and upholstered furniture. So it's still one of the few that formulate through raw material. They buy isocyanate, they buy polyol, they buy the catalyst, they produce the cone, they buy the blowing agent, and they formulate according to the knowledge that they have acquired. In the automobile or automotive industry, nobody formulates in that way. There was a time when they reached a conclusion that it would be easier to sell products in the form of a component. I prefer to call that a two-component system. In practice, many call it polyol and plus isocyanate. I don't really like that terminology because that is very misleading. For those who work with polyurethane systems and polyol plus isocyanate, they think that polyol is a product, but actually it's not. Polyol is never a product. It could be a blend of polyols with all the other additives and catalysts and silicone, blowing agents, all of it mixed in the polyol component because the isocyanate is very reactive, and to mix anything with isocyanate, you would have to have extremely dry raw material. And that is very confusing because if you're working with the system polyol, you think that buying a polyol and replacing it, that's going to work, but it won't. And each polyol has its own characteristics. When I decided to study polyurethane, I had formulated a lot, and I suffered a lot with that. I developed the manufacturing process for a type of polyol and tried to create formulations with different applications using that polyol. And when it didn't work, I was thinking, well, why does it work with one polyol and doesn't work with the polyol that I developed? So in my PhD studies and postdoctoral studies, I focused on the correlation between properties and structure, because some properties will only be obtained with certain characteristics of raw material. So PU properties are connected to the characteristics of the raw materials that are used. So I'm talking about polyol. If we consider the most widely used PU in the automotive industry are the so-called PPGs, polyoxypropylene glycol, in upholstered products and mattresses. So the number of OHs is 56 in that case, and mainly ending with secondary hydroxyl. In the automobile industry, we're going to use polyols similar usually with a molecular weight that's a bit higher, approximately 6,000, to give you the resiliency that the segment in volume in the automotive industry are the seats. So we make PU foam with resilience similar to the foam that was used before PU foam came about. It was rubber latex foam, and that had the resilience of 60%. So high resilience foams were developed with polyols with a higher molecular weight. So the higher the weight of the molecular weight of the polyol and the less the hydroxyl, the resilience of the foam will be lower. Other polyols are used and in other applications in molded PU. So in molded PU, so the molded PU is very similar. So actually the automotive industry is very similar to the other area of other molded PUs. The equipment that's used is the same. So the basic difference is how you formulate the two components. And another thing that I'd like to call your attention to is an example. It's not going to be from the automotive industry, but it's valid because it's right in front of me. So this laptop case is probably made from thermoplastic material. It could be made from PU. And many conferences and trade shows, you've probably seen this before. The ones that are made in PU. And why do you make it from thermoplastics? Just because of cost. And in the automotive industry, I graduated in 1967. So my first car was a 1960 Herbie. Everything was metal on the inside. Metal dashboard, resin steering wheel, completely different than the cars that we have today. And PUs were the materials, because since we have a large number of raw materials available, with the PU, we can formulate products that go from extremely soft products up to extremely hard products. So all the metallic parts in the interior of early cars were progressively replaced by PU components that in some cases were later replaced by thermoplastic products just because of cost. Currently, the car dashboards, except for the premium cars, they're made from thermoplastics. And so are the bumpers. But in the past, everything was made from PU. PU may have a disadvantage of cost, but nowadays, the focus of development is on the environment. When you have a car dashboard made of polypropylene or the bumper, it's a material that would take centuries or even 1,000 years to be degraded in the atmosphere. It's very hard to degrade them. And PU, especially depending on the composition of it, and I'll talk a lot about that for those who are interested in the talk that I'm going to give in the PU conference. The PU, depending on its structure, can be easily, first of all, it will be degraded easier than polyurethane thermoplastic based on polyethylene that takes 1,000 years or centuries to be decomposed in the environment. So depending on the structure, PU will be it will be degraded in an easier way, and nowadays that's the focus of all developments. I'm from a time, and I believe that this still happens, that whoever formulates a PU system for the automotive industry that we're talking about, the focus is to consider the properties that are part of that standard. You need to have the properties for a car seat or for a steering wheel or for the headrest and so on. But I believe that we'll start thinking of formulating, not only thinking about the properties, but also thinking about how the material will be biodegradable and the possibility of the material being recycled.
Então, se a gente tem a maior parte, os poliols, eu falei, os poliols mais
so polyols more widely used are polyether polyols. The ether bond and the urethane bond is very stable, very hard to break the urethane bond to recycle the material and recover the material to create a new product. Another important thing is that there is such a thing as recycled polyol, but leads to a lot of confusion because recycled polyol is nothing to do with the original polyol. The structure is different, the properties that are given are different, and in the automotive industry, I haven't heard of any cases yet of companies that are recycling their raw material, and in some cases they reutilize them in making automobile seats, which is the segment that has a higher volume, and the losses are connected and they're used on the sides of the automobile seats. The PU is like a game of chess. So the amount of raw material available with different structures that will give different characteristics to PU will enable us to formulate materials with the most diverse characteristics. That's why PU is widely used in the automobile industry.
This image illustrates the huge amount of PUs that are used in the automotive industry. You can see, at first glance, almost everything inside a vehicle was some type of PU. As I said, afterwards, they were replaced by thermoplastic materials. In the manufacturing processes, usually we use a two-component system. A two-component system. So we have an isocyanate component, which is usually called isocyanate. And I'm repeating this because I know that some people get this mixed up. Most of the times, the isocyanate component is the polymeric MDI, but it can cause some mix-up because of isocyanate blends. I have formulated this type of system. Sometimes you can't achieve the property you need for that demand. You have to improve the tear of the product. In PU, I'm not going to have time to go deep. In addition to my book, for those who are interested, we also give PU courses. It does take longer, obviously, and I can go into these details. Here at this short talk, I'll try to summarize. The more linear the PU structure, you will have a better resistant to tear. If it's not, the tear will be worse. So sometimes you need to blend a polymeric MD with modified MDI that has lower functionality so that you reticulate your PU piece less to improve certain properties. That's why many times we have blends of isocyanates in the formulation. The same for polyol. Sometimes you achieve the property that you want using only one polyol, but sometimes you need more than one. You put a chain extender to increase the hardness, and all the additives are added to the polyol component because isocyanate component is very reactive. Isocyanate reacts to almost anything. Any compound that has an active hydrogen atom, which is one that is not connected to carbon, will react to isocyanate. So it's not going to react to polyurethane, but it reacts to our skin, to our mucosa. So those who work with pure isocyanate have to take some precautions. Polymeric MDI is the most widely used because it's the safer. It's the only one that at room temperature has a concentration of less than 15 ppms, which is the standard to consider the product safe. So we have isocyanate and polyol. Both components are blended inside the machines that I will mention briefly through a very simplified schematic. So we have a preconditioning of both the liquid components, and all the processes do the same. They adjust temperature, remove air or dissolved gas, and adjust the nucleating gas. One thing that happens in all foams, the number of cells for any foam can be a seat for a car, a mattress, a car steering wheel. The number of cells depends on the air that is nucleated in the nucleation process, which depends on the speed of agitation. If it's high, you end up having a very large nucleation. If it's small, you have bigger cells. And also the use of tensioactive agents. If you put water in the liquefier, you're going to have large bubbles. If you put a drop of detergent, the air disperses. And what happens with all PU foams is that those little drops of air that are dispersed, we have two reactions. The reaction of polio with isocyanate, which is another reaction, and also water, unless PU is solid. And you have water in the formulation. Water reacts to isocyanate, forming carbamic acid that decomposes into amine, and this amine reacts with isocyanate to create polyurea. And bringing these two equations together, a water molecule reacts with two molecules of isocyanate, releasing CO2, which expands the foam. And then it migrates to the nucleated air bubbles. If you put an expansion agent, it will migrate to these air bubbles. The foam will grow. And in all cases, without exception, in the stacked form foam, it will open, and rigid it will close. It all depends on technology. But this nucleation process is the same in all cases. Another thing that happens for those who work with molded PU, you want uniform cells. So you mix the components, and one thing that's very important, and the way that you pour the components in all cases, not only for the automotive industry, that happens with rigid foams, slab stock. The right thing to do is to pour the reacting mix of all the components the most laminar way possible inside the mold. For rigid foam, it can be in a refrigerator cabinet. If those who make mattresses, it can be inside a box, but it has to be very laminar because then the foam grows, and this is critical in the automotive industry because when you pour in a non-laminar manner, you can drag air. Let's say that you pour it into the mold. That will create a turbulence, and the air can be trapped, the atmosphere air, and the polymerization reaction starts, and that air might not come out through the tube. Then you're going to have bubbles in the foam. So the way you pour or inject the system with the two components already mixed, you have the dosing pumps that dose these components, and afterwards this is poured inside the mold. And one important thing, that's why I use this example, if we do this with thermoplastic is ready to use. If I make it with PU, the chemical reaction will happen at the real time in the mold. If you study the system, you will see how you obtain those properties that are the ones you desire. If you change the proportion, the percentage of the agents and change the temperature, any change you do, if you change the temperature of the mold, will change the product that you're making, and that can cause defect on the part. And when I give training sessions at on site at companies, one thing is the person who made the system. The other is the person who is going to work with the system to produce the different parts. So you have to do exactly the same. And it's very common for you to speed up to increase production. And now to conclude, since I'm out of time, another thing that is important that causes a lot of problem in all the parts that are molded. Some molds are simple. Some molds are complex. Sometimes you can inject in one spot, but if you have a mold full of entrances and relief, if you inject in one single spot, you might not be able to fill out the entire mold. So this is all done experimentally. The person operating the process in their daily activities has to get this right so you don't have any problem for production. And you have to determine the profile that you pour inside an open mold. If you have an automated system, you can set up the computer to do it always the same way. The advantage is that you won't have any trouble. My time was short. I hope that I clarified some of your these topics, and in my experience, these are the ones that cause most problems with those who work with this type of product. Most of the companies that manufacture automotive parts, the major problem during the process are these topics that I covered. So it's worth considering working this way. Thank you for your attention, and I'm open to answer any questions you might have. Do we have any questions from the audience? Professor, thank you very much. Your talk was very interesting as always. Thank you very much. Thank you everyone.